Joining us today is Jeff Goumas, Senior Product Sponsor with McGraw-Hill Education. Jeff has over 15 years of experience in education with extensive experience in teaching, research, and development of a number of wide variety of mathematics programs for learners ranging from kindergarten to adult. He is passionate about making mathematics accessible to adult learners through emphasis on making mathematical connections across concepts and real-world application of concepts and skills, and through empowering instructors to help their learners discover these connections. With that, I'm going to turn it over to you, Jeff.
All right, good afternoon, everybody. Thanks for taking time out of your schedules to join us for applying the Common Core State Standards in your high school equivalency classroom mathematics webinar. This is the third one in the series that we've been doing as part of our adult education leadership series. And as Allison said, yes, I am pretty passionate about mathematics instruction, having developed programs both for elementary, middle school, and high school, as well as professional development programs for K-12 and adult education in mathematics. So it is something that's near and dear to my heart, and hopefully I can convey some of that passion to you as you're looking at the standards and the shifts that have happened in adult education over the past couple of years, and be able to apply some of the strategies that we look at today to your classroom. I want to start by just a quote from me, and my quote today is "Do as I say, not as I do." You've probably heard the term mile wide and inch deep as it applies to both mathematics education and education in general. And unfortunately today, because of the volume of topics that I feel are important within the very limited time frame that we have together, I will be doing a bit of a mile wide, inch deep, approach. I want to talk today about a number of things as they pertain to mathematics instruction in adult ed. The first thing that we're going to be looking at are the Common Core State Standards and the College and Career Readiness Standards and sort of the relation between the two. And in doing that, what we're going to be looking at as identified by the College and Career Readiness Standards for adult education, the three key shifts in the mathematical standards for adult education that have come about as these new standards have been incorporated into K-12 and adult education classrooms. Those three shifts are focus, coherence, and rigor. And we're going to be looking at each of those things in detail, talking about what they mean and how they apply to you. And finishing with connecting the standards to the high school equivalency exams that I know many of you are probably here for in terms of learning about how these standards impact what you're teaching in the classroom as you prepare your adult learners for the new wave of high school equivalency exams that are out there. And we're out there starting January 2nd of this year. In terms of how we go about looking at each of these topics, I do want to talk about sort of the relevance of each of these things. How does this impact you as an instructor, as an administrator, as you're instructing your students, as you're looking for materials to use and curriculums to use for teaching mathematics to your students? Action, what will I need to do in order to accommodate this shift for my learners? So what are the strategies that you are going to need to employ on a daily basis and into your daily teaching practice in order to take some of these key shifts and apply them to what you're doing with your learners? And finally, looking at outcomes and what does success look like for an adult learner who is truly mastering the standards and becoming mathematically proficient. And so we'll be looking at that as well and how you can facilitate your students as they produce outcomes and become mathematically proficient. So first, we are going to look at the shifts in the standards, what they are, what this means, and understanding how these impact student expectations moving forward in adult education. So as you are probably aware, the Common Core State Standards are a K-12 set of national standards that were developed by the National Governors Association. And they, at present, are adopted by most states and have two assessments aligned to them, which will be released in the fall of this year, the PARC and the Smarter Balanced, which are two assessment consortium, that various states have adopted and will be using to test student mastery of the Common Core State Standards. The College and Career Readiness Standards are a subset of the Common Core State Standards, and those came out in spring of last year, and they were developed in part to take the Common Core State Standards and determine what applications of those standards were relevant for the adult education classroom. So just a quick comparison between the two. Again, the Common Core State Standards were released in June 2010. They've been around for a fair amount of time, and there's been a lot of motion in K-12 to adopt them, to figure out how to implement them into the classroom, and this year in particular to prepare students for the testing that is going to start happening next year in the fall. College and Career Readiness Standards were released in April of this year. They were developed by OVE in partnership with MDR Research Associates, and again, they were based on recommendations from experts across adult education for which of the Common Core State Standards should be used within adult basic education and adult secondary education. The Common Core State Standards obviously are comprehensive across K-12, and one of the things that's distinct about the Common Core State Standards in comparison with previous standards initiatives is that they sought out, in particular, feedback from employers and from post-secondary institutions to really, truly identify what outcomes students need to have in order to be fully prepared for college and career readiness. So that employer input in particular is important and does sort of indicate that these are in fact relevant for adult education as well. Whereas the Common Core State Standards are, again, grade level, they're sequenced by grade, and in math actually 9 through 12 is one sort of set of standards for mathematics. The College and Career Readiness State Standards are stratified by levels A through E, and we'll look at that in more detail in terms of what that means grade level equivalency-wise. Both are state adopted, their choice. These are not mandates in any sort of way, and as we know, there are a number of states that have chosen not to adopt the college or the Common Core State Standards, and there's been a lot of movement in terms of people sort of shifting away or wanting to shift away, probably much in part of fear for the fact that in the coming year there's going to be a tidal wave of change happening as these standards are implemented. It is also adopted or choice within adult education. There's only a handful of states that have actually adopted the College and Career Readiness Standards for adult education, but they are important because of the alignment of the new high school equivalency assessments to them. So in the case of the Common Core State Standards, the standards are the basis of the assessments. So the PARC and the Smarter Balanced Assessment Consortium both are tests to determine student mastery of the Common Core State Standards. In the adult education world, partly, in fact, because of the fact that these were released not until April of 2013, the current editions, at least, of the GED, TASC, and HiSET tests, which are the three current high school equivalency exams out there, they align to the College and Career Readiness Standards, but they weren't necessarily built on them. You will hear folks say that they fully are aligned to the College and Career Readiness Standards, but they certainly weren't built upon them because the testing that has to happen for those tests in order to be valid come January 2014 of this year could not have happened with the standards being released so late into the game. In terms of the key comparisons between the two, there are sort of core standards within both reading, language arts, and math that carry over both in the Common Core State Standards and the College and Career Readiness Standards. So within language arts, sorry, okay. I guess that went away. Within the language arts standards, there are 10 anchor standards. standards, and those are part of both the CCSS and the CCRS. And in math, in particular, there are the 8 mathematical practices. And these are layers that apply across the grade level standards, content standards within each of the sets of standards. Again, grade level specific standards for the Common Core State Standards. But with the college and career readiness standards for adult ed, they are stratified based on grade level equivalency span. So you'll see there's levels A through E and the corresponding grade levels that are equivalencies that relate to each of those levels. And for math, when we look here at C and D, it's the ones on the right that apply. So level C is grades 4 through 5 with some of the grade 6 standards from the Common Core State Standards, and grade D sort of straddles grade 6 as well, with a heavier focus on the grade 7 and 8 standards from the Common Core State Standards. So why do we need different standards for adult education? Well, for one, when they were adopting these standards, the average adult learner spends typically about 100 hours, within a calendar year in an adult education setting. So there was obviously the clear difference in the fact that a K-12 learner is spending 12 years within a classroom and 180 days a year, whereas an adult learner has limited time and they need to get through the learning that they need for college and career readiness far quicker. But we also have to look at adult learning theory, and the father, I guess, of adult learning theory, Malcolm Knowles from 1984. The learning experiences and interests of adults are obviously different than those of children. So one of the only things when adopting the standards for college and career readiness that folks were able to change on the panel was the wording. There's a number of examples within the standards that obviously pertain more closely to the experiences of K-12 students and adults. So in those cases, there were allowances for the wording to be changed within the college and career readiness standards. Also, adults are self-directed learners, and adults generally know exactly what they want in terms of outcomes from their education. And so we really needed to take the standards and focus them upon the career and college readiness needs of adults. And so that is sort of the basis for how the college and career readiness standards were developed and pulled from the Common Core State Standards. Within what was pulled, there were 3 main shifts, and that's going to be the real focus of what we talk about today. Shift 1, it was focus, plain and simple, to focus strongly on where the standards focus. And this has been an issue for a while in mathematics instruction in general. Within K-12, the National Council of Teachers of Mathematics, they released their standards in the early 90s. And in around 2005, they actually added a layer on top of the NCTM standards and practices called the focal point. And the reason was, as we started today's discussion, this whole notion of mile wide and inch deep. You could be exhaustive in terms of the number of concepts that you're teaching, but if you don't get into the in-depth conceptual understanding that is needed within the choice topics required for each grade level or each span, if we're talking adult education, then you're not going to dig deep enough for there really to be conceptual understanding and proficiency in terms of the student being a mathematician. So one of the key shifts is sort of, in a sense, a mandate to really look at the standards and to focus primarily on the standards that are indicated for a grade level or for a range of levels within adult education. Shift 2 is coherence. The standards are only as good as the progression that students are moved through. So if a student is going through very disparate experiences, whether they're moving from place to place or starting and stopping at different times in life, if they don't have a coherent progression from where they are today to where they're going tomorrow with their mathematics instruction, they're not going to get the in-depth conceptual understanding that is needed for them to be successful in college and career. So when designing curriculum in particular, both within a particular specific program, such as a high school equivalency prep, an ASE, or an ABE numeracy classroom, it really is important that there is a thoughtful time spent to developing this coherence and making sure that the learning experiences are connected as students make their progression through these learning experiences. And shift 3 is really rigor. And we're going to spend a fair amount of time talking about rigor. This is pursuing not just getting the right answer, but truly digging at whether or not students understand the concepts, whether they have fluency within the skills. And we know the term fluency from reading, and we know what that means, but we often don't necessarily apply it to mathematics. But it is equally important in mathematics and in numeracy that students are fluent and we know how to assess what fluency is. And all of these need to be pursued with equal intensity. So now we're going to dive into the key shifts. When we talk about focus and when we talk about coherence in particular, it really is just a matter of the application and understanding what it is you're supposed to teach. I'm just going to go back a second here. These two up top, focus and coherence, really are looking at building that roadmap, building that curriculum, selecting your materials so that you are clearly identifying what it is students need to know at each level and clearly mapping out how they're going to progress from level to level. That is something that could be done at a state level, at a localized level, and that's something that folks really are going to determine on a case-by-case basis. Rigor, however, really looks at what we're asking students to do with the mathematics. And just because they're in a level B or grade level equivalency of 2 to 3 in terms of an adult education level, does not mean we should not be expecting rigor in terms of really mining from the student what their conceptual understanding is, how well they understand the concepts, how they can apply the concepts, how they can model the concepts, how they can talk about the concepts, how they can discuss it. So rigor is something that applies throughout, and strategies for doing that is what we're going to look at and get to that section. So the first is focus. And the thing about adult numeracy, which I said earlier today, there's some key issues in adult numeracy that make this focus a little difficult, or have classically made adult numeracy, something that has not been at the forefront of what we're teaching. The first is that, again, with that term fluency, we apply it to literacy, but adult numeracy is often subsumed under literacy. As adult educators, we do tend to focus on, in particular, reading instruction. We also have the responsibility of teaching things such as life skills and other skills that aren't necessarily normally part of a classroom experience. And limited attention is typically given to the skills that truly define adult numeracy. We look more at outcome in terms of students deriving the correct answer and moving on from that point. Adult numeracy has multiple definitions in terms of what is sufficient in terms of student understanding. And again, it's very easy to fall into that pattern of, I need to get this student from here to here. They're getting the right answers in this exercise, so we're going to move on. That is not numeracy. That is memorizing most often. We like to drill and kill and make sure they can add, subtract, multiply, divide. We also like to, figure out how problems are presented on a test and make sure that they understand the procedures that would be needed to solve that type of problem. But the world is different now, and these tests are much more adaptive. They're much more varied in terms of the problems that students are experiencing. And so memorizing a procedure or an approach based on the way a test presents it is not necessarily going to lead to student success, not just on the test, but certainly not beyond. And again, it is that test-driven attitude towards adult numeracy that has made us fall short mathematically. And we also focus too heavily on computation and operations. And many of these things are things that I think everyone probably on this webinar are aware of. So when we're looking at focus, I really just want to walk through what it is the college and career readiness standards for adult education are and what is contained within them within the mathematics standards. So the first thing to understand is there's the two layers of the mathematics standards. There's the mathematical practices, which is the first one. And as we said, these are shared and adopted 100% from the Common Core State Standards, and they truly are a layer of student behaviors that we should be monitoring, modeling, and assessing as students are learning the concepts that are defined by each of the grade level strands. So there are 8 mathematical practices, and I'm not necessarily going to talk through each of these extensively, but they're making sense of problems and persevering in solving them. So this is just true problem solving and understand how to approach problems. Yes, you need to teach procedures in terms of operations, but there should be, once there is some sort of procedural fluency, we need to immediately have students applying these and teaching them how to determine when to apply different operations to different problems. The ability to reason abstractly and quantitatively, the ability to construct viable arguments and critique the reasoning of others. So this is really looking at discourse in mathematics and having students discuss mathematics. That is not typically something that we see in mathematics classrooms. It's more students are doing exercises, and then we're talking through the problems once they're done. Modeling with mathematics is the 4th practice, and that's a really important one, particularly when we're looking at the high school equivalency level. When we look at those standards, they actually have asterisks next to each one, in which modeling is an expectation of student behavior with that standards. To use appropriate tools strategically, we all know what that means. That could be using a calculator when you need to use it. That could be using various problem-solving strategies when needed to solve problems. Attend to precision is the 6th one. That's obviously checking your work, making sure that you are calculating correctly, double-checking your work, working backwards to make sure that you approach the problem correctly. To look for and make use of structure, and to look for and express regularity in repeated reasoning. In terms of understanding the CCRS based on how they're presented, there are domains, just like there are in the CCSS, and those are typically what the mathematical domains or the mathematical strands, so statistics and probability, number sense, geometry, algebraic reasoning, measurement. Those are the domains. Then you'll see there's always an overarching standard statement. And so that is sort of a global understanding that students are going to need to come to. And then the standards themselves are listed underneath that. And so these are the discrete skills that we want students to understand based on the standards within this domain. In terms of how the standards progress across the grade levels, this is typically what they've looked like, and we're going to talk more about this when we look at the coherence portion. That's the 2nd focus, or P-shift, excuse me. So you'll see in the earlier grades, and this applies to K-12 as it does to adult basic education and adult secondary education, there's a heavy emphasis at the start of mathematics instruction on number sense. And it doesn't really go away ever, because it is the foundation, in particular for algebraic reasoning, which does become the more important focus towards the tail end of a course of study. But you'll see that there's an interesting balance between number sense, excuse me, and algebraic reasoning, whereas one sort of shrinks in terms of focus, the other increases. And there are definite reasons for that because of the bases in terms of number properties and operational properties that apply to algebra and that need to be fully understood by students in order for them to be algebraic thinkers. So the 2nd layer of the standards in terms of focus are content. And so based on that chart, this is sort of what we're looking at when we look at each of the levels. Level A, which again is grade level equivalent K through 1, there's a really heavy focus on number sense. We're talking base 10, addition and subtraction with 20, up to 20, excuse me, and algebraically really just looking at the understanding of equations, what signs and variables mean, and doing basic things with that. Geometry, it's really just describing and reasoning about shapes. When we get to level B, we're looking at addition and subtraction up to 1,000, exploring strategies for multiplication and division, but not necessarily doing anything beyond 1 and 2 digit, mostly 1 digit. And then introducing the concept of fractions, which is an important basis for future works with rates and ratios. Measurement and geometry, nothing more than standard units of measure and understanding rectangular arrays and areas. That's an important concept, and we'll look at it when we look at coherence, that the basis of arrays and areas is actually connected obviously to geometry, but it becomes connected also to operational sense when looking at multiplication, and further down the road, algebraic sense in terms of understanding patterns and looking at how numbers and shapes can be modeled to demonstrate mathematical patterns algebraically. Grades 4, 5, and 6 gets a lot more heavy in terms of what's covered, and this really is the basis for everything moving forward. So this is sort of the linchpin point at which a student moving into, in particular, or what we've classically called a pre-GED or a middle school level equivalency program for high school equivalency test prep, they really need to have mastered these level C skills in order to be fully ready for those. One thing you're going to note is where algebra, I'm grouping with algebra at the level C, is geometry, because geometry does play a crucial part in algebraic understanding and reasoning algebraically. And it is much more easily done when you're using the visual examples that can be provided with patterns and arrays that were built upon in level B. Data analysis and probability comes into play more at level C, and looking at measures of central tendency in particular, and looking at sampling, data collection, and statistical questioning. Level D is where we're looking at in terms of, again, what was typically called the pre-GED level, or the middle school level equivalency for adult learners. So now we're getting into, you'll see less number sense, dealing with positive and negative numbers, but far more algebraic reasoning in terms of expressions and inequalities and actually using functions to describe relationships. And there's more. So geometry remains a pretty heavy emphasis, and then there's also an increased emphasis in the statistics and probability, in looking at probability in particular and gaining an understanding of that concept. And then finally, grades 9 through 12 is almost entirely heavy hitting on algebraic reasoning, and it's looking at both algebra and number sense in terms of rationality and understanding irrational and rational numbers, quadratic expressions and polynomial expressions, and various expressions that relate to number sense and algebra. You're also going to see that algebra is grouped with geometry at this level, again, in looking at how rates and relationships apply to models, congruence and similarity, now that's more geometry, and then determining volume of three-dimensional shapes. And then statistics and probability, really looking at causation and correlation and being able to do things with data. So as we said, the standards are only as good as the standards are if a student is making their way through them in a logical progression and there's connections being made. So it really does require strong planning in order for students to really make their way through this progression with success. And I want to show you what that means. So if we look first at, say, the K through 2 level, we can look at something like base 10 numeracy, composition, and decomposition, which is understanding how to put together and break apart numbers. So we know that this array represents 10. And we know that there are multiple ways that a student could calculate the total number here. One student could count. That is a way of solving this problem, which is how many numbers, how many circles are there. One student might add 7 because they see 7 red circles, and to 3 because they see 3 blue circles. And they're understanding the concept that 10 is comprised of 7 and 3. Another student may do that differently, and they see 5 in the top row, they see 2 more in the bottom row, and they see 3 more blue in the bottom row as well. So that's all well and good. These are students solving a problem, and they're all deriving the correct answer. But when we're talking about being mathematical thinkers, it is the questioning that we provide students and push students through that makes the connections for those students and help them understand how mathematical concepts are tied together. So when we're looking at the approaches of student 2 and student 3, how are they similar? Well, they are looking at this in terms of red and blue. One is just counting the red probably and adding 3. One is looking at red as a set of 5 and a set of 2. And does it matter which color you begin with might be another question. So this starts looking at both with the first question here, the associative property, and then mattering which color you begin with, looks at the commutative property. No, it doesn't. You can count these in any order. You could add the blue first and do 3 plus 7 equals 10. It does not matter. What matters is that it's 10, and students are dabbling in discussing their approaches to how they solve this problem. So as we progress into higher levels and stay within the numeracy strand here, now we're looking at arrays again, but it's not the 5-5 base 10 model that you would do in an earlier classroom, but it's looking at arrays from an operational standpoint and looking at multiplication. So here again are different students' approaches to solving this problem. One student may add. One student may add differently. They see four columns of 3 as opposed to 3 rows of 4. One student may multiply 4 times 3, and one student may multiply 3 times 4. They all got the correct answer, but they all arrived at it differently. And this is a key teachable moment when you are presenting problems to students in particularly a whole class environment, is don't just stop at finding the right answer. Have students explain their reasoning or model their reasoning on the board or wherever, and have students discuss one another's reasoning and explain one another's reasoning. So if you ask the question, which approaches are correct here or which are incorrect, why? Well, none of them are incorrect. They are all correct, and there's reasons for. And you can start getting at, again, the commutative property when you look at students 3 and 4. And then you can also look at just how various approaches can be used with students 1 and 2. The second question I put here is, which approaches are most efficient? Why? This is a key element of mathematical proficiency, is not just knowing how to get the right answer, but developing an understanding of what approach is going to be the most proficient and the fastest for me to get to the right answer. And that's particularly important in a testing environment, but also as a life skill, knowing how to efficiently derive an answer mathematically. So a great follow-up question when you're looking at various student approaches is, which of these is more efficient? Why? Also, having students persuade others in terms of why their mode of approaching this problem was more efficient than someone else's. So as we continue down this progression and we look now at sort of high level 5 or grade 5, excuse me, early grade 6, now we're taking this progression of these arrays in numeracy and we can apply it to geometric principles in algebraic reasoning. So looking at perimeter and area of various shapes. So we can now substitute variables for actual amounts of measurement and look at why we're adding to find perimeter, looking at why we multiply to find area, and in particular that array concept for multiplication does form the basis of understanding length times width equals area. This tends to be one of the easier geometric concepts for students to understand if they've learned array models for multiplying in earlier years, and explaining why it is they multiply. And then finally, we can continue this concept into true algebraic reasoning. So they've learned that perimeter is adding the 4 sides of a square or rectangular figure. But now we're looking at a series of figures that it builds upon each other. There is a geometric pattern involved, but there's also an algebraic pattern involved. So you're looking at the first figure is easy to calculate. The perimeter is 8. It's 2 plus 2 plus 2 plus 2. And the area is 4 feet, 2 times 2. When you go to the second figure, however, that becomes a little bit more complicated. On the area side, it's easy because we're looking at composition again, and this is just building off on itself. And spatially, there's no overlap. The figure is growing at a linear rate. So it's 4 plus 4 is 8. So you know that you can just keep adding 4. Perimeter-wise, however, there's an overlap between the two figures, and students need to understand that and figure out what that means. Now, a student could look across this and see a very simple pattern with area increasing by 4 feet squared each time, because again, it's just adding on to itself. And perimeter, if they're clever, they look from figure 1 to figure 2, see that it increased by 6. They look at figure 2 to 3, they see that it increased by 6. And so when they're looking at the perimeter and area for the fourth figure of this pattern, they can very easily deduce that, okay, it's going to be 26 is the perimeter in feet, and that the area is going to be 20 feet squared, because I'm just adding, and the pattern is add 4, and the pattern is add 6, add 6. That's all well and good. But now when you get into understanding, well, what would the 27th figure of this pattern be? Students need to start employing an understanding of algebraic understanding. And they need to be understanding how to represent things like this overlap here between the two figures. So we're looking at variables, we're looking at concepts that they've mastered geometrically with area and perimeter, and applying it to patterns and algebraic problem solving. So here are two students' approach, both of which are going to derive the correct answer. This student sees that addition of 6, and they see that they start with a base perimeter of 8. So they're clever enough to say, well, 6 is going to represent the increase that happens here. And the figure is n, so figure 1 would be here, 1 minus 1 is 0, times 6 is 0, so the perimeter is 8. I can test it out with the second figure and plug in 2. 2 minus 1 is 1 times 6, plus 8 is 14. And so this pattern is going to work for me. And they might look at 2 times 2 times n, because it's 2 times 2 is the area, and times 1 times 2 times 3. That is how these are increasing. Student 2 has probably a more sophisticated approach to this, because they understand that 8 is always going to be the base. And then they also understand that this overlap can be represented by the fact that in this case there is one overlap, and because of that, 1 foot of perimeter is lost from this figure, and 1 foot of perimeter is lost from this figure. And so it is the number of the figure minus 1 times 2, because of the number of sides that are lost in terms of perimeter space. And so this is the equation that this student comes up with. And they've also done something here where they've simplified the equation, which is an important part of algebraic understanding. So looking at these progressions, again, of the coherence and connecting the concepts that students are learning from level to level is really important, because they truly do build upon one another. How do we ensure coherence? Well, it's difficult because there are differences in K-12 and adult education. But the important thing for you to think about as you are adopting your curriculum and developing your curriculum for students is to make sure that when you're looking at programs, to evaluate their alignment to these standards that are out there, because that's going to be your key to understanding that as a basis, the program is aligning to the standards and ensuring that different teachers teaching at different levels are going to provide some level of coherence with the base materials that they're working to. But again, at a state level, at a local level, it really is important to adopt a clear curricular roadmap that defines what students are supposed to learn at different levels and to adhere to it. The third shift is rigor. And this is really where we're going to look at how do we assess this? How do we really get at student understanding? And I'm going to say that it really is quality over quantity. It is not the number of problems that we throw at students, but it's what we ask them to demonstrate with the problems that we present them with. And I don't know if folks have ever seen this, but there's 5 strands of mathematical proficiency. And this is what we're going to walk through when we talk about rigor and we talk about how to assess student understanding. Conceptual understanding, procedural fluency, strategic competence, adaptive reasoning, and productive disposition. And these actually come from the National Resource Council, which has a number of wonderful pieces of research on adult numeracy that I urge folks to look at. Now, these are all well and good. You may be hearing some terms in there that relate to these depth of knowledge indicators that we've talked about and that you've seen if you've been doing anything in the high school equivalency space over the past year. There is overlap between the two. The difference between the two, however, is when we're looking at testing and we're looking at, say, the GED samplers or the GED practice test or the task practice test. Each one of those items has a DOK level assigned to it. So it is the sort of highest level that the student sort of needs to be at in order to answer that problem. And that's well and good for evaluating the rigor of the problem. However, if we're going to instill mathematical proficiency in our students, it's not just one of these things that we should be doing with students. It really is looking at all of these and making sure that they're hitting the mark. So conceptual understanding is really looking at concepts and definitions. It's understanding what a right angle is and being able to explain it. It's looking at examples and non-examples. So looking at things such as a right angle or something that's not a right angle, and being able to explain why one is or why one isn't, why something is a rectangle, why something isn't a rectangle. So the pure definition and understanding of the concept and what it is, and the ability to make mathematical connections and relationships. How we promote this really comes down to teacher modeling, and it's crucial. One of the things that I always stress within the programs of professional development that I do with teachers is that students shouldn't be using mathematical terminology. If they learn the term congruence, they should be using the term congruence. And we as teachers owe it to them to show them how to communicate with mathematical language. So make sure that students are communicating their understanding clearly by using mathematical terminology and by explaining how they approach their problems. So it's not just about them getting the right answer, but it is also explaining how they approach it, because that is how you as an instructor are going to know if they truly understand the concept and didn't just derive the correct answer. Procedural fluency is looking at how students carry out procedures. So this is how they add, subtract, multiply, divide, and do all of the various operations. Doing it flexibly, doing it accurately, doing it efficiently and appropriately. Let's face it, efficiency is important, particularly when taking a test. So speed, which sometimes is developed through drill and kill type activities, is a necessary part of being successful, particularly when you're in a timed environment. So procedural fluency is important because it is the basis for being able to do higher level mathematics. If you can't add quickly, then a problem that requires addition, subtraction, and multiplication in order to get to the right answer is going to be daunting for a learner. So again, that term fluency, we can equate to it when we look at reading, and if a student can't read words, we know they're not going to be able to read Chaucer. It's the same thing in mathematics. They cannot do higher level thinking if the basic procedures that are needed for that higher level thinking, they don't have a concept of. So how do we promote procedural fluency? We provide extensive opportunity to practice and apply the procedures that they've learned. We provide non-examples for them to evaluate. So if you want to truly get at if a student understands how to apply a procedure, show them an answer that's wrong and show someone's mathematics behind them and have them figure out where did this person go wrong in making this calculation. And provide real-world examples. Use spreadsheets for monthly budgets and calculating phone plans. It's not just about actually executing the procedure, but knowing when to apply it. A spreadsheet is a great way to do that because you can have the student show on a monthly budget, say, what their debits are, what their credits are, what their monthly bills are, what their sort of other expenses are, and fill them in. And those may vary from month to month. And so now you're looking at not only order of operations, and adding and subtracting in the order, but you're also looking at variability in numbers, and you're looking at things like variables and algebra. One of the things when we look at procedural fluency that's really important is the importance of recharging. And I bring this up because in adult education and in all education, we tend to sort of shelve those concepts that we've finished. We teach a concept, a student does a review, they get an 80%, and we check a box, they know this. Well, the problem with that is if they're not recharging with that skill, they tend to forget it. So what this is a forgetting curve, and it is by a German psychologist, Hermann Ebbinghaus, who in the late 1800s conducted extensive research on how much we forget and how much time it takes to forget. And what he basically did was memorize strings of syllables that were nonsensical, but extensive amounts of them, and got to the point where he had 100% memorization. And at that point, he deemed himself as having learned something new. Well, it came to be that after about a month's worth of time of not recharging and reusing those, he only retained about 21.1% of what he had learned. And he did this study repeatedly on other subjects. And after 60 months' time, it was down to lower than 10%. So when we're looking in particular, prepping our students for the high school equivalency test, we have to make sure that we are recharging them and giving them opportunities to practice it, not just at the point of instruction, but beyond that. What Ebbinghaus did is develop patterns for when reminders or when recharging should happen to see how far up the forgetting curve could go and basically be more of a retention curve than a forgetting curve. So the first reminder after a few days saw marked results after 60 days, up to over 40%. A second reminder after about 10 days in instruction gave that 60-day time frame about upwards of 80%. And finally, the magic number that he wanted to get to after a third reminder of a month was that after 60 days, there was 90% retention within his subjects. So this is a really important thing when we're looking at the fluency in particular, that just because they know how to do it now, it's just like you and I learning a new computer skill. If we learn some new program and then don't use it, 2 weeks later, we've forgotten 90% of what we've learned. So the importance of recharging can't be stressed enough when we're looking at mathematics instruction, in particular looking at procedural fluency. Strategic competency is really a three-tiered concept, and it looks at both knowledge and skill, which is something that you can use, but it's also attitude and confidence. And a person is not strategically competent unless they really feel confident when they are approaching mathematics problems. So this really is looking at the ability to apply strategies to solve math problems and to know what strategies to use when approaching them. So things such as making diagrams, looking for patterns, solving simpler problems are all important strategies that we need to be instructing with our students. The ability, again, to explain reasoning, you hear me saying that often because it's crucial that students can communicate their understanding of mathematics. How do we promote this? Well, we first model mathematical problem-solving strategies. So they're not going to know the process of solving a simpler problem unless it's shown to them. And they look at, okay, you look with numbers that are tangible and then see if there's a pattern that you understand. That's how you can solve these problems that deal with larger numbers. Explaining their approach, and in particular explaining someone else's approach, is really a really effective means of having students show their strategic competence and understand that there are multiple ways to solve a problem. And again, there's efficient and more efficient ways of doing so. Adaptive reasoning is learning how to not just understand a concept or a strategy within one particular environment, but be able to use it in different environments and know how to reason mathematically. In particular, this is looking at employing the correct strategies for the context and persuading others how to use these techniques. So looking at that efficiency in terms of what's the most efficient way for me to get at the correct answer. You may call it cheating, but if it is going to get the right answer and you're showing that understanding of the concept in your reasoning, then it probably isn't. So this is really looking at being adaptive in your approach to math, using the tools that you have available to you and knowing the best way to solve a problem. Again, this looks at being able to explain how a procedure is correct or incorrect and more importantly, being able to explain why a strategy is more efficient than another. So when we looked at some of those earlier problems, when we looked at competence, explaining why a strategy is more efficient is really important. This both comes from strategic proficiency, but also in terms of being adaptive mathematically. And finally, the fifth strand of mathematic proficiency is productive disposition. And this is looking at using math confidently and competently in various situations and being able to relate the math that you're learning to how you're going to use it. This, again, takes teacher modeling. This takes teacher explanation and explaining and making meaningful connections to students as they're learning math concepts and meaningful connections from the math to real-world career and real-life experiences. So one of the things that I say with productive disposition in particular, it's sort of the sink or swim kind of mentality, but there is a need for us to allow students to struggle more. And there was great research done in the 90s called the Trends in Mathematics and Science Studies, where they looked at high-performing mathematics countries and looked at what were the key differences in terms of how math was instructed in those countries. And the two sort of key elements, one was making mathematical connections between and across concepts, but the other was allowing students to struggle. What we tend to do in our classrooms, and this is across the board, is we'll walk through how to solve a problem. We will show the steps on how to solve a problem. Then we'll give an example and ask students to do the same thing, to follow or parrot the steps that we just showed them. What's interesting is if you just pose a problem that may require, there's a more efficient way of doing it with a skill that you are about to teach, but letting them use the tools they already have in their toolbox to try to figure out how to solve that problem with what they have. When you do that, oftentimes they are going to derive a correct answer. It's probably not going to be the most efficient way, and that's going to be what you're going to teach them in today's class. And so you're giving them confidence in applying the skills and concepts that they've already mastered, but then you're also helping make the connections for, okay, you had one approach here, but we're going to learn about how to create a linear equation to solve this problem so that you can figure out what the 37th figure in this pattern is going to be in terms of perimeter. So that struggle is really important because it does solidify those understandings that you don't get if you simply walk through a problem without having them attempt it independently. So when we look at the 5 strands, again, as I said, while a DOK on the test or on the practice test is looking at a particular level of understanding or knowledge that a student is supposed to show, when we are assessing students, we really need to be looking at their fluency or proficiency across all of these strands. So it isn't necessarily a series of steps, but it is more of a woven approach, where with each and every problem, we should be looking at the ways that we can elicit each of these strands in different ways through mathematical discourse and through having students really explain their understanding. So how do we use these standards for lifelong success? And I know what's first and foremost in many of our minds is how the standards relate to the various tests. And I just wanted to provide a quick content comparison across the 3 tests. What we do know is GED and TAFE have a heavy emphasis on algebraic reasoning and function. It's over half of both of these tests and the content on these 2 tests. HiSET, as you can see right now, and we do know that they're going to have a phased approach as they move into the coming years. Right now, however, it's 25% in each of the sort of main strands of math. Number and operations is about 25% of TAFE and 25% of HiSET. And it's not that it's not in GED, but GED sort of has categorized quantitative reasoning into one larger category without much detail in terms of the percentages. Geometry and measurement, again, is about 25% in HiSET and 25% in TAFE. And then statistics and probability, again, in TAFE, it's around like 13%. And then for the HiSET, it's again 25%. All of those 3 above really are captured in the GED test within the quantitative problem-solving problems within that test. And here's where you can go for more information in terms of the 3 tests, and this is obviously dependent on what your state is currently using or where they are going to be going in the future in terms of the high school equivalency tests that they use. But I just want to remind folks that these tests are a means to an end, and they aren't an end in themselves. So while we certainly want to make sure that we're teaching and covering these standards that are part of these tests, the college and career readiness standards really are the vetted roadmap for college and career readiness and success, and that's beyond test day. So how do we do that? We should be applying mathematics across the content areas. I know GED and TAF both have details in terms of how to be using mathematics, particularly statistics, within the science and social studies areas. We should be promoting that in our instruction, making those real-world connections. And really the most important is that mathematical discourse or discussion that should be happening every single day in the math classroom. It's really critical to eliciting those 5 strands of mathematical proficiency and making sure that students truly understand what they've learned. I've gone way over, and I apologize, but I am now going to hand this over to Allison, who's going to walk quickly through a description of some of the things that McGraw-Hill Education is doing to support instructors in their mathematical instruction.
Thanks, Jeff. That was great. I'm just going to take a minute or two to go over some of our new solutions for our Common Core High School Equivalency Series. While I'm doing that, if anybody in the audience has questions for Jeff, go ahead and type that into the question box, and we'll have some time for Q&A after I'm done. McGraw-Hill Contemporary has been a trusted partner in adult education for over 40 years and remains committed to providing you and your students with the resources needed to meet the challenges that we discussed today. We present to you the Common Core High School Equivalency Series. It strives for more than just to help students pass their tests. It offers a budget-friendly curriculum that prepares students for test success while developing the foundation for ongoing college and career readiness. Not just aligned, but built from the ground up upon the Common Core and college and career readiness standards, this exciting new series includes a suite of 3 brand new programs: Common Core Basics, Common Core Achieve, and Power Up, getting started with computers and keyboarding. These programs prepare adult learners and educators for the shift in the new standards, adapt to these standards by focusing instruction around evidence-based reading instruction and web depth of knowledge, and help students achieve not only test success, but a strong foundation for college and career readiness. Please visit us at www.commoncoreachieve.com to learn more about each of these programs, download samples, and find your sales rep to schedule a free strategy session. And for those of you who are planning to attend COABE in Pittsburgh next month, we'll look forward to meeting you in the booth and answering all of your questions surrounding the new tests and our solutions. We'll give away classroom packages of Common Core Achieve and daily drawings. So register to win each day and stop by to receive a special gift. We'll see you there. All right, and now we will open it up for some questions about today's presentation. We had a question about whether the high school equivalency series was available in Spanish. It is not available in Spanish yet. We will also be sending out, for those of you asking about sending a recording of today's presentation, we'll be sending that out in a follow-up email in the next couple of days. And I'm just reading through to see which questions we have for Jeff. Okay, Jeff, here's a question for you. Should we consider that conversational mathematical components are now conversational within limits of our understanding, or are we teaching students to host these concepts for later usage for the current and potential outcomes in the workplace?
Well, I personally think it's for both, because, I mean, if anyone's looked in particular at GED and the sample problems, To get a depth of knowledge, you really aren't. You're not just solving problems. You are demonstrating all of those competencies, the strands of competencies, excuse me, that are required for someone to be mathematically proficient. And again, just having worksheets or having students in an online program answering questions and asking them if they understood it is not enough anymore. And that's, I think, for test success, but also definitely for career readiness and being able to use mathematics.
Great. Okay, there's another question on here about what is orange in GED?
Orange in GED in that pie chart was the quantitative problem solving.
Okay.
And that's the percentage of problems on the mathematical reasoning test for the GED that will be dedicated to quantitative problem solving, which does incorporate many of the other strands, as does the algebraic reasoning, which is 55%.
All right, what would you suggest for critical thinking or math reasoning examples or content?
Well, actually, as a part of the follow-up, you're going to be getting some activities that are part of the Achieve program that have, they're called skill builder activities that are discussion-based. When we looked at the sequence of slides earlier and looking at the arrays and that coherence, I tried to build in some questions there that get at some of those competencies that are only elicited if they're done through teacher modeling and teacher questioning. So it really has much to do with students getting to the right answers, but then also working together to talk through student thinking, to have students explaining it. And that can be from anything as simple as approaching just a standard word problem that you see, to doing something more sophisticated and more real world, such as choosing a phone plan and figuring out which phone plan is the best one for you. Because one, you're bringing in not only something that's real world for them, and considering things such as what their data usage is, but also looking at, well, how did you figure out that this is the best phone plan for you to use? What did you calculate? Like, what did you figure your monthly amount would be? And that can be a very engaging discussion because it's something that does apply to students and their real world. But it also does look at different students' approaches and not poking holes necessarily in approaches, but explaining why, again, in particular, one approach may be more efficient than the other, and that, again, would oftentimes be when sort of higher level skills such as algebraic reasoning and using equations to help solve that problem would be used. But it also it helps students really reason and be forced to talk through what their reasoning was. There isn't necessarily a right answer to that question, which phone plan do you want best? But when you start looking at which would be cheaper based on your needs, you do start having to reason mathematically and coming up with validating your thinking. And that's where that discourse and talking through some of the concepts really comes through.
Okay, so the next question is, could you go over again the task breakdown? I think this was in one of your slides earlier on.
Yeah, it was. So task is, and I can pull it up. I have it on a different computer here. Sorry. The task breakdown is, again, more heavily algebra and functions. So algebra is around a little over 25%, or excuse me, yeah, a little over 25%, and then functions as well. I think it's like 23 and 22%. So it comes to a total of just under 55% in terms of the amount that's focused on algebra and functions. Geometry and measurement is 25%, and then I believe number and operations is 13%, and statistics and probability is 12%. I probably should have put numbers in my pie graphs, but you can go to the task website and they do have their blueprints, which really delve into what the exact amounts are in terms of the percentage of problems for each of the strands.
All right, Jeff, I think that was our last question. Let's see. Just a couple of things to clarify before we head off. The Common Core Achieve Math Core Subject module is now available for sale. Oh, the print version is, yep. And if you're interested in learning more about that product, you can go to our website. Again, that's www.commoncoreachieve.com. If we didn't get to your question today, we'll follow up with you via email after the webinar. And I just wanted to thank everybody for attending today and thank Jeff for presenting. We'll be sending a follow-up email with a link to the recording. And also, as you exit the webinar today, a survey will open up, and we would really appreciate your feedback to help us improve and plan for future webinars. If you have any additional questions, you can send those to webinars@mheducation.com. Thanks again, everybody. Have a great afternoon.